Hello everyone, myself Sai Prasad, Alex in Allahabad High School and the Junior College. Welcome to the series of the lectures of Intermediate Second Year Maths A. We started a discussion with our chapter Binomial Theorem. As of now, we have seen all the kinds of problems such as expansion, finding its middle term, nth term and all those terms. Right? We also did most of the problems with the relationship between the coefficients of two different expansions. Right? Now let us directly go into the expansions. We will write all the expansions from now. We'll do most of the expansions problems, that is, we'll just expand, simplify odd terms, even terms, right? Again here also nth term, generalized term and all those, we'll do those kind of things from now. Okay, now see here. The question is given as P and Q are the sum of odd terms and even terms respectively in the expansion of this. Then he is asking us to prove that P square minus Q square is this, 4PQ is this. Clear? Now let us write the expansion for that. X plus A whole power n is equal to NC0 x power z, NC0 x power n, right? NC1 x power n minus 1 A, NC2 x power n minus 2 a square and so on up to NC n minus 1 x power finally this is 1 and a power n minus 1 plus NCn x power 0 and a power n. Is it right? Now let us separate all the odd terms together and all the even terms together. Right? Now see here, this can be written as NC0 x power n plus NC2 x power n minus 2 a power 2 and so on up to NCn a power n plus here NC1 x power n minus 1 a power 1 plus NC3, the next term will be a power n minus 3 a power 3 and so on up to NCn minus 1 x power 1 into a power n minus 1. So he is telling that this is equal to sum of odd terms and even terms. This is P and that is Q. Is it right? We got the value of P and Q. Then what could be x minus a whole power n? So let me write that also. Similarly, x minus a whole power n can be written as NC0 x power n plus NC2 x square a square n minus 2 and so on up to NCn a power n minus NC1 x power n minus 1 a, NC3 a power n minus 3 a cube, this is x Rory. So plus and so on up to NCn minus 1 x power 1 a power n minus 1. Right? Why do we get minus here? Since it is a second term, the coefficient of a is negative. So only for the odd terms a cube we will get the coefficient, the term as minus. Right? Now what is this? Sum of even terms, odd terms. What is the sum of even terms? Right? Now you can just tell that x plus a whole power n is p plus q and x minus a whole power n is equal to p minus q. Now can we multiply these both? He is asking us to find the value of p square minus q square. So what do this mean? First one, he is asking us to find p square minus q square, which is p minus q into p plus q. What is p minus q? X minus a whole power n. What is p plus q? X plus a whole power n. X minus a into x plus a, that is nothing but x square minus a square whole power n. That's what he asked us to prove. Is it simple or not? Yes. Second, x plus a whole square power n, x minus a whole square power n, he is asking us to prove it as 4pq. We can do it in various ways. We can take this and find this, okay, or else we can simplify this and find this. Anything is okay. Done. So what shall we do now is, can we write 4pq? What is the formula of 4pq? Can I write 4pq as p plus q whole square minus p minus q whole square? Why? What is p plus q whole square? P square plus u square plus 2pq. Right? Here p square plus q square minus 2pq. Right? Here it is minus and there it is plus. Okay, and both get cancelled. P square q square will get cancelled. Here we'll have plus 2pq plus 2pq. We'll get 4pq. Right? So what is p plus q whole square? That is x plus a whole power n. So we can write it as x plus a whole power n whole square minus x minus a whole power n whole square. This is nothing but x plus a whole power 2n x minus a whole power 2n. That's what he asks us to prove. Right? What is the main task here? Just segregating the whole expansion as even and odd terms. Clear? And after that, just taking the question and simplifying them in order to get the answer. That's it. Is it not easy to solve? Fine. Shall we move on to the next problem? Let's do. Look at the question here. He is telling, using binomial theorem, prove that 50 power n minus 49n minus 1 is divisible by 49 square. Did we see this kind of question somewhere? Yes, we saw in mathematical induction. So, just we will prove that this term is equal to 49 square into some term. Till there it's fine. Yes or no? So, we have to prove it using binomial theorem. How do we do? Just see here. So, let us write what is given. 50 power n minus 49n minus 1. Since here it is written as 49 and 1, let me write 50 as what? 1 plus 49 whole power n. Isn't it? So, let us write this as 1 plus x whole power n formula. So, what do we get? nc naught x power n plus nc1 49, nc2 49 square, nc3 49 cube and so on up to ncn 49 power n. Is it right? 0, 49, 49 square cube and so on up to 49n. Right? Minus 49n minus 1. Now if we observe, what is nc1 n? What is nc0? 1, right? nc0 is 1 and here it is n into 49 plus here it is nc2 49 square, nc3 49 cube plus and so on up to ncn into, let me write it as 49 square into 49n minus 2 minus 49n minus 1. Right? Now if you observe 49n, 49n, 1, 1 will get cancelled. Right? Why did I write 49 square into 49n minus 2? So that we can take 49 square common from all the terms. 49 square, if I take it as common, I will be left with nc2, nc3 into 49 and so on up to ncn into 49 power n minus 2. This whole thing is obviously a positive integer. Why? NCN terms can never be negative. That is first thing. Second, there are only positive signs here. Third thing, since it is only 49 power something, so obviously it can not be negative. So this is nothing but 49 square into some positive integer. So this is divisible by, therefore 50 power n minus 49n minus n is divisible by 49 square. Right? The question is a kind of difficult question, but simplifying it is very easy. This can also be done by mathematical induction, which is a very long question. Here it is simple thing. Isn't it? Shall we go to the next problem? Let's do. Look at the next question here. He gave I, n are positive integers of 0 less than f less than 1, and 7 plus 4 root 3 whole power n is equal to I plus f. What is I? Integer. F is some kind of fraction. Okay, then he is asking us to show that I is an odd integer and I plus f, 1 minus f is equal to 1. Okay, so let us take that 7 plus 4 root 3 whole power n first. Given 7 plus 4 root 3 whole power n is equal to integral factor, integer plus a kind of fraction. Okay, till there it's fine, we know that is what they gave. Then he is telling that this f is a fraction which lies between 0 and 1. Then how do we prove now? Just tell me. First let us assume, let 7 minus 4 root 3 whole power n is I minus f. Right? First of all, what is this 4 root 3? What is 4 root 3 ka square? 16 3s are 48. So 48 lies between 7 and 6. Right? What is 6 square? 36. 7 square? 49. 4 root 3 ka square is 48, which lies between these two. Okay? Now, let me apply all minus now. If I apply minus, this will be minus 6 greater than minus 4 root 3 greater than minus 7. Okay, now let us add 7 all to the terms. This will be 7 minus 6 greater than 7 minus 4 root 3 greater than 7 minus 7. Isn't it? Now just check here. 7 minus 6 is 1 greater than 7 minus 4 root 3 greater than 0. Since it is to the power n, let me apply power n to all the terms. So what does it become? 1 is greater than 7 minus 4 root 3, power n is greater than 0. So what does this mean? This is 1 greater than capital F power n is greater than 0. Simply 0 is less than f is less than 1. Right? Here if you observe, 7 plus 4 root 3 is an integer with a small fractional number, whereas 7 minus 4 root 3 is also a fractional number which lies between 0 and 1. Right? With this both the information, let us write what is this f and what is this I. Fine. Shall we add both the terms now? Let's see here. I plus f plus capital F. What is this? 7 plus 4 root 3 whole power n. This is 7 plus 4 root 3 whole power n, and here 7 minus 4 root 3 whole power n. Okay, 7 minus 4 root 3 whole power n. Is this in the form of x plus a whole power n? Yes, right. So this is 7 power n into nc naught plus nc1 7 power n minus 1 into 4 root 3 whole power n, 4 root 3 power 1 and so on, plus here nc naught 7 power n minus nc1 7 power n minus 1 4 root 3 whole power 1 and so on. Right? If you clearly observe, here all the odd terms will get cancelled and all the even terms will remain the same. So that is nothing but double of nc naught 7 power n, nc2 7 square, n minus 2 is into 4 root 3 whole square and so on. Isn't it? So from this you can clearly observe that I plus f plus capital F is always an even integer. Clear? So he is asking that I is an odd number. When can I be an odd number? Only when small f plus capital F is always equal to 1. So how do we do that is, given that 0 is less than small f is less than 1 and 0 is less than capital F less than 1. So what does this mean? 0 less than f less than 1 and 0 less than capital F less than 1. If I add those both, I will get 0 less than f plus f is less than 1. So what is an integer which lies between 0 and 2? Tell me. The integer which lies between 0 and 2 is nothing but 1. So simply f plus f is equal to 1. Right? Since f plus f is equal to 1, obviously what is the value of I? The value of I is always an odd integer. Therefore, I is always an odd integer. Did you understand? Why? Because since I plus f is an even number, here f plus f itself is 1. So, I will be always equal to 2 into some term minus 1, which is obviously an odd number. Right? Now look at the next question. I plus f into 1 minus f. What is it? I plus f into 1 minus f. That is, what is I plus f? I plus f is nothing but 7 plus 4 root 3. I plus f is 7 plus 4 root 3 whole minus n into, what is 1 minus f? That is nothing but capital F, right? This is capital F. What is capital F? 7 plus 4 root 3 whole power n into 7 minus 4 root 3 whole power n. Now if you observe a plus b into a minus b, what is it? A square minus b square, 7 square minus 4 root 3 whole square whole power n. That is 49 minus 48 whole power n, which is 1. Is it right? That is what he asked us to prove, right? So the main thing here is you have to just observe the range of small f and capital F. Both are less than 1. So it is a kind of fractional term. It is not at all an integer term. Clear? So just by this theoretical calculation we could prove that I is always an odd integer. After that, here we could write that I plus f is equal to into 1 minus f is equal to 1. Is it clear? Fine. What all we did for today? We just started with the coefficients problem, then we did a few expansions thing, and then we did this kind of problem. Clear? Fine. This is for today. Let us meet in the next session with the more problems of binomial theorem. Thank you.